The year is 1938. In a workshop at the Springfield Armory in Massachusetts, an assistant foreman named Walter Campbell holds a partially machined rifle receiver in his calloused hands. His eyes narrow as he examines something the engineering team has missed for months. Something so small, so seemingly insignificant, that it had been overlooked by some of the finest military minds in America. A tiny metal protrusion, no larger than a grain of rice, had been machined away during production, and that minuscule absence was about to doom America's revolutionary new rifle. But we're getting ahead of ourselves. To understand how Walter Campbell saved the M1 Garand and perhaps changed the course of history, we need to go back to a small farm in Quebec, Canada, where a boy named Jean Cantius Garand was born on the first day of 1888. The Garand family lived a modest life on that Canadian farm, one of 12 children raised in the rural countryside of Saint-Remy. Jean, who would later go by the name John, was the only one of 6 brothers to use his first name. The others went by their middle names, but tragedy would reshape young John's childhood. When his mother passed away in 1899, his father made the difficult decision to move the entire family south, across the border to Jewett City, Connecticut. Imagine being an 11-year-old boy, uprooted from everything you've ever known, thrust into a new country where you don't even speak the language. John Garand found himself sweeping floors in a textile mill, his small hands pushing a broom back and forth across dusty wooden planks. Hour after hour, day after day, the rhythmic sound of the looms echoing through the cavernous factory. But young John wasn't just sweeping floors. He was absorbing everything around him. The massive machines, the precise mechanisms, the way gears meshed and pulleys turned. His mind was a sponge, soaking up the mechanical ballet that surrounded him. And slowly, word by word, he learned English from his fellow workers. By the time he was 18, John Garand had already proven himself extraordinary. He had developed and patented 2 inventions, a telescopic screwjack and an automatic bobbin winding machine. For someone who had started as a floor sweeper, this was remarkable. But it was his work at a shooting gallery that would change his trajectory forever. There, among the crack of rifles and the smell of gunpowder, John discovered his true passion. Firearms, the precision, the engineering, the way a single pull of a trigger could release such controlled power. He was hooked. Garand moved through various jobs, always learning, always innovating. He worked in tool-making firms in Providence, Rhode Island, and New York City. He mastered forging, welding, steam engineering. Every skill he acquired was another tool in his mental workshop. And then came 1917, the year that would change everything. The world was at war, the Great War, they called it, the war to end all wars, and America was preparing to join the fight. The United States Army put out a call for designs for a new light machine gun, something portable, reliable, devastating. John Garand, now working in New York City, saw his opportunity. He had been sketching designs in his spare time, working through mechanical problems in his head, while his hands performed their daily tasks. Now he had a chance to make those sketches real. He partnered with another designer, John Kewish, who agreed to pay Garand $50 a week and develop his design. They worked feverishly, racing against time and competing designers. In June of 1918, they had their first prototype ready. They demonstrated it to Hudson Maxim, brother of the famous gun designer Hiram Maxim. Hudson was impressed enough to recommend them to the Naval Consulting Board. From there, they were passed to the Army War College, then to the Ordnance Department. The War Department turned down their design. The war ended in November of 1918, too late for Garand's machine gun to see action. But the government had seen something in this Canadian immigrant, something valuable. In November of 1919, John Garand was offered a position as a consulting engineer at the Springfield Armory in Massachusetts. He accepted. He would work there for the next 34 years. The Springfield Armory was hallowed ground for American firearms. It had been producing weapons since 1794, arming soldiers through the Revolutionary War, the War of 1812, the Civil War, the Spanish-American War, and the Great War. Its brick buildings sat along the Connecticut River, their windows overlooking the water like vigilant sentries. Inside those walls, the finest gunsmiths and engineers in America plied their trade. John Garand's assignment was clear: design a semi-automatic rifle to replace the bolt-action M1903 Springfield. The Springfield rifle was a fine weapon, accurate and reliable, but it was slow. After each shot, a soldier had to manually work the bolt, ejecting the spent cartridge and chambering a new round. In the rapid-fire chaos of modern warfare, this was a fatal disadvantage. The Army wanted a rifle that could fire as fast as a soldier could pull the trigger, without manual intervention between shots. It sounds simple, doesn't it? Just make a rifle that loads itself. But the challenge was immense. The rifle had to be reliable in mud, in sand, in rain, in freezing cold and blistering heat. It had to be accurate at distance. It had to be simple enough for a 19-year-old farm boy to field strip and clean. It had to be manufacturable by the millions. And it had to do all of this while firing the powerful .30 caliber 30-06 cartridge that the Army had standardized. Other nations were working on similar problems. The Germans had their Gewehr 43. The Soviets had their Tokarev. But these would come later, and none would be issued as standard equipment to every rifleman. America wanted to be first. America wanted to be best. John Garand started with a primer-actuated system, using the backwards motion of the primer to operate the action. He built prototypes labeled M1922, but the system wasn't practical with the standardized cartridge. He switched to a gas-operated system, tapping the expanding gases from the fired cartridge to cycle the action. This was more promising. The years rolled by. 1923, 1924, 1925. Garand worked in the model shop, surrounded by the smell of cutting oil and the whine of machinery. He tested different designs, different calibers. The military kept changing their requirements. First, they wanted .30 caliber, then they wanted .276 caliber, then back to .30 caliber. Each change meant months or years of redesign. In 1927, the Cavalry Board ran trials comparing the Thompson, the Garand, and the .03 Springfield. No clear winner emerged. More trials in 1928, more trials in 1929. Garand's design kept improving, but so did the competition. A designer named John Peterson had his own rifle in the running, and Peterson was a heavyweight in the firearms world. John Moses Browning himself had called Peterson the greatest gun designer in the world. By 1932, it came down to a head-to-head competition. Peterson's T1E3 versus Garand's T3E2. Both rifles were chambered in .276 caliber. Both were gas-operated. But there was a crucial difference. Peterson's rifle used a delayed blowback mechanism with a toggle joint similar to a Luger pistol. It was elegant, sophisticated. But it had a fatal flaw. It needed lubricated ammunition. Without lubrication on the cartridges, the action would seize up, and that lubrication system attracted dust and grit like a magnet. Garand's rifle, with its rotating bolt and gas piston, didn't need lubricated ammunition. It was simpler, more robust. The military chose Garand's design, but then came another wrinkle. General Douglas MacArthur intervened. He insisted the rifle be chambered in the standard .30-06 cartridge, not the smaller .276. The entire rifle had to be redesigned again. Finally, on January 9, 1936, the rifle was officially adopted as the United States Rifle, caliber .30, M1, the M1 Garand. It had taken 17 years from Garand's first sketches to official adoption. 17 years of trial and error, of late nights and failed prototypes, of political maneuvering and changing requirements. But now, America had its rifle. Production began slowly. The Springfield Armory had to tool up for mass production. It wasn't just about building rifles one at a time in the model shop anymore. This was industrial-scale manufacturing. thousands of rifles, tens of thousands, eventually millions. Every part had to be precisely machined. Every component had to be interchangeable. A soldier in the field had to be able to swap parts from different rifles and have them work perfectly. John Garand didn't just design the rifle. He designed the tooling to make the rifle, the broaching machines, the milling equipment, the gauges and jigs. He was a master not just of firearms, but of manufacturing. Many of the parts were made using broaching, a relatively new process where metal is pressed or squeezed into shape under tremendous pressure. It was faster and more precise than traditional machining methods. By August of 1937, Springfield Armory was producing M1 Garands on a regular schedule. Not many yet, maybe 100 a day, but it was a start. The rifles were handmade, essentially. Skilled craftsmen assembled each one, checking tolerances, fitting parts, test firing. These early rifles performed beautifully. Every test they were put through, they passed with flying colors. But the world situation was darkening. In Europe, a man named Adolf Hitler had come to power in Germany. In Asia, Japan was expanding aggressively. War clouds were gathering on both horizons. If America was going to arm its military with the M1 Garand, production needed to accelerate dramatically, and that meant moving from craft production to mass production. The military made a decision. Springfield Armory would develop the production techniques and machinery, then share that knowledge with civilian contractors who could produce rifles by the hundreds of thousands. Companies like Winchester and International Harvester and Harrington and Richardson. But first, Springfield needed to prove that mass production was possible. They set up production line tooling, automated processes. Each rifle would move from station to station with specialized machines performing specific operations. It was the difference between a master chef preparing a meal and a restaurant kitchen, with each person handling one task: efficiency, speed, volume. And that's when the problem appeared. The rifles coming off the new production line weren't performing like the handmade ones. They looked identical. The measurements were within specification, but there was a malfunction. A mysterious, baffling malfunction. When firing through a loaded 8-round clip, the rifle would jam on the 7th round. Not every time. That was what made it so maddening. Sometimes the rifle would fire all 8 rounds perfectly. Other times that 7th round would fail to feed properly. The bullet would nose upward, jamming against the top of the receiver instead of sliding smoothly into the chamber. The bolt would be stuck halfway, unable to close. The rifle was useless until the shooter manually cleared the jam. The engineers at Springfield Armory were bewildered. They tore rifles apart. They examined every component under magnification. They measured tolerances to thousandths of an inch. Everything checked out. The parts were identical to the handmade rifles. So why were they jamming? And there was another bizarre aspect to the problem. The jam only occurred when the top round in the clip was loaded on the right side. If the top round was on the left, the rifle fired perfectly, every single time. The 8-round en-bloc clip used by the M1 Garand held its cartridges in a staggered, double-stack arrangement. 4 cartridges on the left, 4 on the right. When you loaded the clip, the topmost cartridge could be on either side, depending on how the ammunition manufacturer had loaded it. And somehow, impossibly, the rifle could tell the difference. Picture the scene at Springfield Armory. Engineers huddled around a disassembled rifle, arguing theories. The smell of gun oil and cigarette smoke thick in the air. Coffee cups forgotten and cold. The pressure was immense. Not just professional pride, though, that was significant. The entire M1 Garand program was at risk. You see, the Army had decided to showcase their new rifle at the 1938 national matches at Camp Perry, Ohio. Camp Perry was where the best military and civilian shooters in America gathered to compete. It was where reputations were made and broken. The military brass, many of them competitive shooters themselves, would be watching. If the M1 Garand jammed repeatedly at Camp Perry, word would spread like wildfire. The rifle would be doomed before it ever reached the battlefield. The national matches were approaching fast. Weeks away, then days, and they still didn't understand why the rifle was jamming. The decision was made to send rifles to Camp Perry anyway. What choice did they have? But they implemented a desperate stopgap measure. Every clip of ammunition destined for Camp Perry was inspected. If the top round was on the right side, the clip was unloaded and reloaded with the top round on the left. It was tedious, painstaking work, and it was only delaying the inevitable. They couldn't ask every soldier in America to load his ammunition a specific way. The real problem had to be found and fixed. At Springfield Armory, the investigation intensified. Senior engineers examined the problem. Junior engineers examined the problem. Ordnance officers examined the problem. They developed theories, tested them, discarded them. The gas system? No, that checked out. The operating rod? No, it was functioning correctly. The bolt, the extractor, the ejector? Everything was within specification. And then Walter Campbell made his discovery. Walter Campbell was an assistant foreman at Springfield Armory. Not a senior engineer with advanced degrees, not a famous designer, just a skilled gunsmith and machinist who had worked at the armory for years. His hands knew metal. He could feel when something was off, even if he couldn't immediately explain why. Campbell was examining the feed system, trying to understand how the cartridges moved from the clip into the chamber. He had a partially finished receiver in his hands, one that had been stopped partway through the machining process, and he noticed something. 2 vertical ribs ran along the inside of the magazine well, fore and aft on each side. These ribs guided the clip, keeping it stable as the follower pushed the cartridges upward. Campbell picked up a finished production receiver. The ribs were there, but they looked different, shorter, especially the right forerib. The one on the front right side of the magazine well. At its top there should have been a small projection, a nub, really. Nothing dramatic, just a little raised section, maybe a 1/16 of an inch tall. It was gone. Campbell felt his pulse quicken. He grabbed another production receiver. Gone. Another. Gone. Every production receiver he examined. That tiny nub had been machined away. He found one of the original handmade receivers, built by John Garand himself in the model shop. The nub was there. He understood now. When the barrel was installed in the receiver on the production line, the machining operation was cutting through that nub. It was easier that way, faster. The machines were set up to remove material in that area to facilitate barrel installation, and nobody had realized that tiny protrusion served a purpose. Campbell examined the feed system more closely. When the clip held 8 rounds, it was stiff. The spring steel gripped the cartridges firmly. But as rounds were fired, the clip became more flexible. By the time only 2 rounds remained, the 7th and 8th, the clip wasn't holding them as tightly. The cartridges could shift slightly. That tiny nub on the right foreguide rib, its job was to press gently against the cartridges, keeping them oriented correctly, even as the clip flexed. Without it, when the top round started on the right side, that second-to-last cartridge, the 7th round, could tilt upward as the bolt came forward, just a fraction of an inch, just enough to catch on the edge of the chamber instead of sliding in smoothly. It was brilliant in its simplicity, and maddening in its obscurity. This entire crisis, threatening to destroy America's revolutionary new rifle, came down to a piece of metal smaller than a peppercorn. Campbell brought his findings to the ordnance engineer, A.L. Woodworth. Woodworth ran tests. He took a production receiver and welded a small piece of metal back onto that right foreguide rib, recreating the missing nub. He assembled the rifle and tested it. Top round on the right. All 8 rounds fired perfectly. He tried again and again. No jams. The fix worked. Word reached Colonel James L. Hatcher, the officer in charge of Springfield Armory's experimental department. He was Julian Hatcher's brother, another prominent figure in military ordnance. Colonel Hatcher examined Campbell's discovery. He studied the original Garand design drawings. Sure enough, those ribs were supposed to extend all the way to the top, with that small nub intact. Somewhere in the translation from prototype to production, that detail had been lost. There wasn't time to redesign the barrel installation process before the Camp Perry matches. Instead, they went with a direct repair. The 200 rifles destined for Camp Perry were recalled. Skilled welders carefully added material back to the right foreguide rail on each receiver, recreating the missing nub. The welds were ground smooth, polished, refinished. You couldn't tell the rifles had been repaired unless you knew where to look. And then those rifles went to Camp Perry. Picture the scene: Ohio, late summer, the shores of Lake Erie. Shooting ranges stretched out in the morning sun, targets dotting the landscape like distant scarecrows. The smell of gun oil and cut grass, the pop and crack of rifle fire. Competitors in shooting jackets, settling into prone positions, cheeks pressed to stocks, eyes focused through iron sights. And there, the new M1 Garands, waiting to prove themselves, or fail spectacularly. Major Julian Hatcher was there, watching nervously. Every shot fired through an M1 was a test. Every successful feeding of that 7th round was a relief. Would the fix hold? Would Campbell's simple solution, that tiny welded nub, be enough? The rifles performed flawlessly. 8 rounds. Reload, 8 rounds. Reload, no jams, no failures to feed. The 7th round slid into the chamber as smoothly as the first. The competitors were impressed. The military brass was impressed. The M1 Garand had passed its most important public test. Back at Springfield Armory, the production process was revised. The tooling for barrel installation was modified, so it no longer removed that crucial nub. Every future M1 Garand would be built correctly, and for the handful of early production rifles that had already been made with the defect, repair procedures were established. As rifles came back for maintenance, armorers would check the guide rail and weld it if necessary. The crisis was over. But think about how close it came to disaster. If Walter Campbell hadn't noticed that missing nub, if he hadn't understood its purpose, the M1 Garand might have been rejected. America's infantry might have gone into World War II with bolt-action rifles, just like in World War I, at a disadvantage against enemies who would develop their own semi-automatic designs. Instead, American soldiers landed on the beaches of Normandy carrying M1 Garands. They fought through the hedgerows of France, the winter forests of the Ardennes, the islands of the Pacific, all with Garands in their hands. And that rifle gave them an edge. A German or Japanese soldier with a bolt-action rifle could fire perhaps 15 aimed shots per minute. An American with an M1 Garand could fire 40 to 50. That's a 3-to-1 advantage. That's the difference between winning and losing a firefight. General George S. Patton called it the greatest battle implement ever devised. Not just good, not just adequate, the greatest. That's high praise from a man who knew warfare intimately, but none of it would have happened without Walter Campbell's keen eye and understanding of how metal and mechanisms interacted. He didn't invent the rifle. He didn't design the feed system. He just noticed something everyone else had missed, a tiny detail, an absence so small it seemed insignificant, and yet it was everything. The story of the M1 Garand is often told as John Garand's story, and rightfully so. He spent 17 years perfecting that design. He deserves the recognition. But behind every great invention are dozens or hundreds of people whose contributions are forgotten. The machinists who built the prototypes, the test shooters who fired thousands of rounds, the engineers who solved small problems that never made headlines. Walter Campbell was one of those people, an assistant foreman, a working-class tradesman. His name doesn't appear in most history books. There are no statues of him. When people talk about the M1 Garand, they talk about Garand and Patton and the soldiers who carried it. Campbell is a footnote, if he's mentioned at all. But on that day in 1938, when he picked up that partially machined receiver and noticed what was missing, Walter Campbell changed history. Let's talk numbers for a moment. By the time production ceased in 1957, more than 6.5 million M1 Garands had been manufactured. 6.5 million. That's a rifle for every person in modern Massachusetts. Each one of those rifles had that tiny nub on the right foreguide rail. Each one fed its 7th round cleanly, because Campbell had noticed its absence. Those rifles saw service in World War II, in Korea, in the early years of Vietnam. They were used by American troops, by South Korean forces, by the Philippines, by Italy, by numerous other nations. They were still in use by National Guard and reserve units into the 1970s. Think about how many lives might have been saved because American soldiers had reliable, fast-firing weapons. How many firefights were won because of that 3-to-1 rate of fire advantage? We can't calculate it precisely, but it's not zero. It's a real number, representing real human beings who came home to their families, all because of a tiny piece of metal that almost got forgotten. The broader lesson here is profound. In complex systems, especially those pushed to the limits of performance, small details matter enormously. A difference of a few thousandths of an inch can be the difference between success and catastrophic failure. This is true in firearms. It's true in aircraft. It's true in medicine. It's true in software. It's true in any field where precision matters. Engineers and designers create the big picture. They calculate stresses and forces, design elegant solutions to complex problems. But it's often the craftsmen, the people with their hands on the actual hardware, who notice what the calculations miss. The way a part flexes under load, the tendency of material to bind in certain conditions, the small compromises made during manufacturing that seem insignificant until they're not. John Garand was humble about his achievement. He never received royalties for his rifle design. When over 6 million rifles were produced bearing his name, making millions of dollars in revenue for military contractors, Garand himself saw none of that money. He had transferred all rights to his inventions to the United States government in January of 1936. It was the price of government employment. He was paid a salary. A good salary, rising from $34,000 a year in today's money to about $140,000 by the end of his career. Comfortable, but not wealthy. A bill was introduced in Congress to award him $100,000 in appreciation. It didn't pass. Bureaucratic inertia and political considerations killed it. Garand never complained publicly. He received awards instead. The Meritorious Civilian Service Award in 1941. The first Medal for Merit in 1944, shared with Albert Hoyt Taylor. The Alexander L. Holly Medal from the American Society of Mechanical Engineers. Induction into the U.S. Army Ordnance Course. Hall of Fame in 1973. He worked at Springfield Armory until his retirement in 1953, at age 65. He continued to design. In the late 40s and early 50s, he worked on a bullpup rifle design, the T-31, with the magazine behind the trigger group. It was radical for its time, select fire capable, firing rate around 600 rounds per minute. But when Garand retired, the project was incomplete. It was eventually scrapped. Garand remained in Springfield, Massachusetts, for the rest of his life. He became a regular visitor to the armory, even in retirement. He would walk through the shops where he had spent 34 years, watching new generations of craftsmen building rifles. He passed away on February 16, 1974, at age 86. He's buried at Hillcrest Park Cemetery in Springfield. Walter Campbell's later life is less documented. He continued working at Springfield Armory, no doubt contributing to numerous other projects and improvements. But his moment of glory was that discovery in 1938. That realization that something small was missing, that understanding of why it mattered. The 7th round stoppage became a part of M1 Garand lore. Even today, more than 80 years later, people argue about it on internet forums. Some claim you still can't load an M1 clip with the top round on the right, or you'll get jams. This is myth. The problem was fixed in production rifles. Any M1 Garand manufactured after mid-1938 has that nub in place. Load the clip however you want. It will feed correctly, but myths persist because they contain a kernel of truth. There was a time, brief but real, when orientation mattered, a time when the future of America's most important infantry weapon hung in the balance over a piece of metal you could hide under your thumbnail. Let's bring this back to the human element. Imagine being a soldier in World War II. You're 19 years old, fresh from a farm in Iowa or a city in New York. You've been handed this rifle and trained how to use it. You trust it with your life. When you squeeze that trigger, you expect it to fire. When you need to shoot again, you expect the next round to chamber. That trust is built on the work of people like John Garand, who spent 17 years perfecting the design, and people like Walter Campbell, who noticed what others missed. In combat, there's no second chances. If your rifle jams at the wrong moment, you don't get a do-over. The soldier who made it home because his M1 Garand fed all 8 rounds cleanly never knew Walter Campbell's name, never knew about the production crisis of 1938, never knew about a tiny nub on a guide rail. He just knew his rifle worked when he needed it. That's the hidden foundation of military success. Not just brave soldiers, not just brilliant tactics, but reliable equipment. Equipment that works because someone somewhere paid attention to the details. Someone who cared enough to look closely, to question, to understand. The M1 Garand went on to legendary status. It was so successful that many nations tried to copy it. The Italians developed the BM-59, essentially a rechambered Garand, with a detachable magazine and select fire capability. The U.S. itself evolved the design into the M14 rifle, which served as the standard American service rifle from 1957 to 1964 before being replaced by the M16. Even today, the M1 Garand is revered. Collectors prize them. Shooting enthusiasts compete with them at matches across the country. The distinctive ping of the ejecting en-bloc clip is instantly recognizable. Pick up an M1 Garand today, and you're holding a piece of history. Wood and steel and American ingenuity. But you're also holding Walter Campbell's contribution, that guide rail with its small nub, precisely where it needs to be, doing its job, keeping cartridges aligned, making sure the 7th round feeds as smoothly as the first. We started this story by talking about how something small saved something big, a tiny piece of metal preventing a massive failure. But there's another dimension to consider, the humility of true expertise. Campbell didn't burst into a meeting and announce he'd solved the problem. He didn't demand recognition. He simply showed what he'd found to the people who needed to know. He let the fix speak for itself. That's the mark of a real craftsman. Not seeking glory, just solving problems, understanding that the work matters more than the credit. In 1941, production of M1 Garands hit 600 rifles per day. By the peak of World War II production, Springfield Armory was churning out 4,000 rifles per day. 4,000. Each one tested, each one meeting specification, each one with its guide rails properly formed. The manufacturing capacity that had been developed, the tooling that Garand and his team designed, the fixes that Campbell and others implemented, all of it came together to arm the largest military force in American history. When the war ended in 1945, American industry had proven what it could do. Not just produce weapons, but produce reliable weapons at scale. The M1 Garand was the symbol of that achievement. A rifle that worked, that soldiers trusted, that enemies respected. There's a recording from 1943, an interview with German prisoners of war. They were asked about American equipment, what impressed them, what worried them. Multiple prisoners mentioned the American rifle. "They fire so fast," one said. "You cannot return fire effectively before they have emptied their rifle at you." The psychological impact was significant. German soldiers knew they were outgunned at the individual level. Japanese forces had a similar experience in the Pacific. Their Type 38 and Type 99 rifles were bolt action, requiring manual operation between shots, accurate weapons, reliable weapons, but slow. When American Marines stormed ashore with M1 Garands, the volume of fire was overwhelming. There are countless stories from veterans. The Marine on Guadalcanal, who held off a Japanese banzai charge, firing so fast his barrel glowed red in the darkness. The soldier in the Ardennes who cleared a building room by room, the rapid fire of his Garand giving him the decisive edge. The paratrooper in Normandy who fought for 2 days straight, his rifle never failing despite mud and rain. Those stories exist because of engineering excellence, because of manufacturing precision, because of quality control, because people cared about doing it right, and because Walter Campbell noticed something missing. Think about your own work, whatever it is. Think about the details you notice, the small things that seem unimportant until they're not. How often do you speak up? How often do you investigate further? It's easy to assume that if something were important, someone else would have noticed, someone smarter, someone with more experience, someone with a fancier title. But that's not how the world works. Expertise comes in many forms. A senior engineer might understand the mathematics of gas pressure and bolt velocity, but a machinist might understand how metal behaves under cutting tools. Both kinds of knowledge matter. Both are essential. Campbell had hands-on knowledge. He had built receivers. He had seen how they were made. When he picked up that partially finished receiver and the finished production receiver and compared them side by side, he could see the difference, not because he was smarter than the engineers, but because he was looking at it from a different angle, with different expertise. This is why diversity of perspective matters in problem solving. Not just diversity of background, though that's important, but diversity of experience. Different people notice different things. The designer sees one aspect, the manufacturer sees another, the end user sees a third. Optimal solutions often emerge from integrating all those viewpoints. Springfield Armory in the 1930s was in many ways ahead of its time in this regard. Yes, there was hierarchy, officers and civilians, engineers and machinists, but there was also communication. Campbell could bring his observation to Woodworth. Woodworth could test it. Colonel Hatcher could implement the fix. Information flowed because people listened. Imagine if Campbell had been dismissed. You're just an assistant foreman. Let the engineers handle this. How long would it have taken to find the problem? Would they have found it before Camp Perry, before the rifle's reputation was destroyed? We can't know. But the fact that he was heard, that his observation was taken seriously and tested, that's significant. The production of M1 Garands continued throughout World War II and beyond. Springfield Armory was joined by Winchester, which produced over 500,000 rifles. International Harvester Corporation, better known for farm equipment, produced over 300,000. Harrington and Richardson produced over 400,000. In Italy, Beretta produced Garands under license in the 1950s. Each manufacturer had to implement the same fix. That guide rail had to be properly formed. The tooling had to be set up correctly. Inspectors had to check. The knowledge that Campbell helped develop at Springfield was disseminated throughout the defense industry. This is how progress works, not just in big breakthroughs, but in accumulation of small improvements. Each problem identified, each solution implemented, each lesson learned and shared. The next generation of rifles, the M14, incorporated lessons from the M1 Garand, and the M16 incorporated lessons from the M14, and the M4 incorporated lessons from the M16, each iteration building on the knowledge of the previous generation. We're now almost 90 years removed from Campbell's discovery. The world has changed immensely. The weapons have changed. Wars are fought differently, but the fundamental principles remain. Attention to detail matters. Small things can have large consequences. Expertise exists at all levels. Good organizations listen to their people. The M1 Garand itself has become a collectible artifact. Museums display them. The Civilian Marksmanship Program sells refurbished examples to qualified civilians. Shooting sports competitions have specific categories for vintage military rifles. When you watch these competitions, when you see an M1 Garand fire 8 rounds in rapid succession, each round feeding perfectly, remember that you're seeing Walter Campbell's legacy in action. The rifle is a system, gas port to gas cylinder to operating rod to bolt to firing pin, feed lips to follower to cartridge to chamber. Every part precisely made, every clearance calculated, every interface engineered, and one small nub on a guide rail, keeping everything aligned. John Garand died in 1974, 38 years after his rifle was adopted. He lived to see it used in 3 major wars. He lived to see it become legendary. He died knowing that millions of soldiers had trusted their lives to his design. That's a profound legacy. We don't know when Walter Campbell passed away. His life after 1938 is largely undocumented in historical records. But every time someone picks up an M1 Garand, every time that 7th round chambers smoothly, his contribution lives on, unsung, unremembered by most, but real. That's how history actually works. Not just famous names and dramatic moments, but countless small contributions by ordinary people. The machinist who suggests a better tool path, the inspector who catches a defect, the assembly worker who notices something doesn't feel right. Civilization is built by the accumulated efforts of millions of people, most of whom we'll never know. So when you hear about the M1 Garand, remember it's not just John Garand's rifle. It's also Walter Campbell's rifle, and A.L. Woodworth's rifle, and James Hatcher's rifle, and the rifle of every machinist and assembler and inspector and test shooter who contributed to making it work. The too small change that made the M1 Garand fire flawlessly wasn't really too small. It was exactly the right size, just big enough to matter, just important enough to save the program, just noticeable enough for one man with calloused hands and a keen eye to see what everyone else had missed. That's engineering. That's craftsmanship. That's how great things get built. Not by lone geniuses working in isolation, but by teams of people, each bringing their own expertise, each contributing their piece. Some pieces are large and obvious, some are small and easily overlooked, but they all matter, every single one.